alaikum. Good morning, everyone. Nice to meet you all. Today, inshallah, we will start together to answer the questions of AS and A-level past papers. AS and A-level past papers, we will start together in paper May-June 2019, paper number 9701 per 12. It is a multiple choice paper. We will start to answer the questions. I will try to explain each point in details for more information. At first, you must know for your multiple choice question, it is allowed to use the data booklet for some questions. We will start. Let's go with the first question. At first, we have Boltzmann distribution for the molecular energies in sample. So we are relating between molecular energies of sample in aqueous hydrogen peroxide at room temperature. We have curve indicating the relation between the number of molecules and kinetic energy. Under the curve, we have number of molecules having specific amount of energy enough for doing the reaction. Which diagram shows the Boltzmann distribution of molecular energy of aqueous hydrogen peroxide maintained at room temperature when catalyst manganese oxide is used? When catalyst manganese is used. When we start to use the catalyst, at first Boltzmann distribution, it is one of the curves used for indicates the relation between kinetic energy and in number of moles. In any chemical reaction, we have number of moles which have enough amount of energy to start the reaction. And when we start to change the conditions of the chemical reaction, for example, when we start to increase the temperature of reaction, or when we start to add a catalyst of the chemical reaction, take care the number of moles containing or have specific amount of energy, enough amount of energy to start the chemical reaction will increase. So, Boltzmann starts to draw relation between the kinetic energy and relative number of molecules. At low temperature, we have a curve, and down the curve, we have a small number of molecules with enough energy to start the chemical reaction. And when we start to increase the temperature, take care, the top of your curve will be lower. And also, you will have greater number of moles with enough energy, greater number of molecules with enough energy to start the chemical reaction. By having greater number of molecules to start the chemical reaction, of course, the number of molecules will finish the reaction will increase. So the rate of chemical reaction will increase. The other curve is indicating the relation between the number of molecules and the relation between energy when we start to use catalyst. When we start to use catalyst in the chemical reaction, we will have increase in the number of molecules from this small number of molecules to this large number of molecules. So it is the two factors related to Boltzmann distribution. In our curves, we want to show relation between catalyst addition and number of moles. Related to our curve, the only curve which is related to increase in the number of molecules during the chemical reaction is B curve. So our best choice is B. If you start to have another look, you will see that the top of your curve will be lower, and also the number of moles gaining higher energy to start the chemical reaction will increase. So the temperature is one of most important factors that can increase the rate of the chemical reaction. Question 2. Question 2. Oxygen has 3 stable isotopes: oxygen 16, oxygen 17, and oxygen 18. All three isotopes are present in a sample of oxygen O2, which has analyzed using a mass spectrometer. In the mass spectrometer, we will start to use sample of substance. A sample of substance will be injected in mass spectrometer, and it will be heated at high temperature till vaporization. After vaporization, we will make ionization for the particles. After making ionization, the particles will gain enough energy to start to move in the mass spectrometer. In the mass spectrometer, the sample will start to be affected with magnetic field. The magnetic field will make deflect for the movement of isotopes. Isotopes means we have different particles of the same element with the same atomic number but different atomic mass. So already we have 3 oxygen atoms with equal atomic number, but they are different in their mass, they are different in their weight, so they are moving with different speed. According to their moving with different speed in the magnetic field, we will start to take the hit of the particle on the spectrum and draw relation between the mass of particle and their relative abundance. So we are talking about relation between mass of particle and relative abundance. In the case of oxygen, if we have monoatomic oxygen, of course we will have 3 peaks, or we will have 3 peaks in the mass spectrum. But oxygen is one of diatomic gases. So in the container already we have oxygen O6, oxygen 16, oxygen 17, oxygen 18. But the oxygen is diatomic molecule. So the molecule is made of 2 atoms. So we have many probabilities for having the mass of the molecule. At first, we may have 2 oxygen atoms, each one of them is 16. So the total is 32. Second one, we can have 2 oxygen atoms. One of them is 16 and the other one is 17. Total is 33. So, of course, we have different mass in the mass spectrum peaks. The other one is 16 plus 18 equals 34. Okay. And then we have 17 plus 17 equals 34. Okay. It is different mass in the mass spectrum peaks. The other one, 18 plus 18 equals 36. And at last, 17 plus 18 equals 35. So our probabilities, of course, we have different masses of the diatomic molecule. The masses which are different, we can detect it on the mass spectrum peaks. Different masses are 32, 33, 34, 36, and 35. So we have 1, 2, 3, 4, 5. We have 5 different peaks on the mass spectrum. So, as general, if we are talking about gas is diatomic. As the gas is diatomic, so we are talking about probabilities. But if we are talking about monoatomic molecule, we will start to take the same number of peaks as the same number of isotopes. Okay? Next one, question 3. The first 8 successive ionization energies for 2 elements of period 3 of the periodic table are shown in the graph. At first, we have relation between ionization energy and electron removed. In the case of the first one, we will start to have very high jump between electron number 7 and electron number 8. The other one, we have a large jump between electron number 2 and electron number 3. What is the formula of the ionic compound formed from these elements? At first, the first ionization energy is the amount of energy required to remove 1 mole of electrons from 1 mole of substance in the gaseous state. So, if we start to have a look in the periodic table, we will see that as we go upright, the ionization energy will increase. As the ionization energy will increase, so we expect to have the highest amount of ionization energy in the upright elements. The greatest jump between the electrons in the amount of energy, it is related to the removing of the electrons are highly attracted by the nucleus. So when we start to talk about highest jump between 7 and 8 electrons, we are talking about halogens. We are talking about some element of fluorine, chlorine, bromine, iodine, and so. And in the next element, we have great jump between second and the third electron. So we are talking about element. When we start to remove the third electron, we will start or we will need very high amount of energy. Why we will need to add high amount of energy? Because we will start to take electrons highly related to the nucleus. So we can say we are talking about elements like elements in group 2 alkaline earth metals, magnesium and calcium. In our question, we are talking about period 3 elements. Period 3 elements, so exactly we are talking about magnesium and chlorine. So the correct answer is magnesium chloride, MgCl2. Fourth question. A sigma bond is made between 2 carbon atoms in the molecule of ethene. Which diagram shows the orbital overlap that occurs to form this bond? At first, you must know that the shape of s orbital is spherical shape. S orbital is a spherical shape. P orbital is dumbbell shape. Dumbbell shape, in the dumbbell shape we have 2 circles attached by 1 node. So we are talking about spherical shape for s orbitals and dumbbell shape for p orbital. We have 2 types of bonds. The first bond are sigma bond between the carbon atoms. And second type of bond is pi bond between the carbon atoms. If we start to talk about sigma bond, we are talking about head by head overlap of orbitals. But if we start to talk about pi bond, we are talking about side by side overlapping. So in the case of sigma bond, we have head by head overlap. But in the case of pi bond, we have side by side overlap. So, of course, we are talking about sigma bond between carbon atoms. So, we are talking about head by head overlap. If we are talking about pi bond, we will choose side by side overlap. If we are talking about sp bond, we are talking about this type of overlap. S overlap, it is the first choice. Okay, next one. The table shows some properties of 4 substances. Which substance could be potassium iodide? At first, potassium iodide is an ionic compound. Potassium iodide consists of metal. Potassium is one of the elements of alkali metals and iodine is one of halogens. So we have interaction between one of alkali metals and we have non-metal. Attraction between metal and non-metal will form ionic bond. As we have ionic bond, ionic bonds have some specific properties. For example, they have high melting point, high boiling point. They cannot conduct electricity in their solid state. They are good conductor of electricity when they are in solution or when they are in liquids or when they are in the molten state. Potassium iodide is solid substance with high melting point and high boiling point, and we said it can conduct electricity in their solution or in their molten state. But they are not good conductor of electricity when they are solid. Okay? So, we will start to read the choices. At first, the melting point of solid. He told you we have solid. As we have solid, of course, we have high melting point. Take care, minus minus, we are talking about the gases. 680, it is expected for ionic compounds. 1600, take care, it is very strong compound. So we are talking nearly about macrocovalent compounds. Electrical conductivity when molten, we said electrical conductivity is related to having free electrons, delocalized electrons, mobile electrons that can transfer and conduct electricity, or related to free ions, can move and conduct electricity. In the case of ionic compounds, when we have molten solution, we have free potassium cations and we have free iodide anions. So, the free movement of ions will be good conductor of electricity. So, the best choice is C. The melting point is 680 and also it is a good conductor of electricity. Question 5. We have relation between X, Y, and Z are all gases that behave idly and react according to the following equation. X gas plus 2Y gas will form 2Z gas. When 3 moles of X and 3 moles of Y are placed in a container with a volume of 1 decimeter cubic, they react to form a maximum amount of Z. The final temperature of the reaction is 120 Celsius. What is the final pressure inside the reaction vessel? We want to calculate the pressure of ideal gas. Ideal gas equation is PV equal nRT. It is the ideal gas equation PV nRT equal nRT, where P is pressure, V is volume of gas, N number of moles, R is the universal gas constant, and T is temperature, but it is calculated in Kelvin, not Celsius. So take care, you must convert the temperature from Celsius into Kelvin. We will go again to the reaction. We have X gas plus 2Y gas will form 2Z gas. We started the reaction with 3 moles of X plus 3 moles of Y to form 2Z. By looking at the reaction, we have limiting reagent, as each 1 mole of X will react with 2 moles of Y. So according to this relation, we can say that each 1.5 mole of X will react with 3 moles of Y to form 3 moles of Z. So by the end of the reaction inside our container, we will have 3 moles of Z and 1.5 mole of unreacted X. 1.5 mole of X not included in the reaction because X is in excess amount. As we are talking about gases, so we can calculate the total number of molecules of gas inside the container after the reaction. Inside the container after the reaction, we'll have 3 moles of Z and 1.5 mole of X unreacted. So the total number of moles is 4.5 mole. So by applying the reaction equation BV equal nRT, we want to calculate pressure P. P equal nRT over V. So by calculating 4.5 moles times R is constant equal to 8.314 joule per mole Kelvin. Joule per mole Kelvin. Okay, so we will start to calculate the value of pressure. The value of pressure is calculated by kilopascal. So we want to convert it into Pascal, like our equation exactly. So start to multiply it by 1000. We will have 10.74 multiplied by 10 raised to the power of 7 Pascal. Ideal gas constant depends on the value of pressure. If we are talking about pressure in atmospheric pressure, we have 0.0821. Kilopascal 8.314. If we are talking about millimeter of mercury, we are talking about 62.4. So take care the value of our constant is related to the unit of measurement of pressure. Okay, next question. Question 7. Which pair of substances are both simple molecular? At first, we will start with carbon 60 and graphene. We are talking about graphene. Graphene is one of macrocovalent compounds. Number 2, carbon 60 and iodine. Of course, iodine is diatomic molecule. As it is diatomic molecule, so we can say it is simple covalent molecule. Graphene and graphite are macrocovalent compounds, so it is cancelled. Graphite and iodine. Graphite is macrocovalent molecule, of course, and iodine is simple covalent molecule. From the following picture, we can start to memorize the allotropes of carbon. Allotropes of carbon are elements exist in different physical states. We have different allotropes of carbon. We have diamond, graphite, graphene, and fluorine. At first, we start with diamond. Take care, diamond particles are arranged in tetrahedral shape. They cannot conduct electricity. They are poor conductor of electricity, and they haven't any free electrons to conduct electricity, and it is the hardest substance in the universe. It is very good piece of jewelry. Graphite. Graphite consists of hexagonal shaped structure of carbon. They are arranged in layers, millions of layers. The layers are connected to each other by bonds and force of attractions. They are very good conductor of electricity because each carbon atom in the graphite is connected with 3 carbon atoms. So each carbon atom has 1 free electron. According to the number of free electrons, so the free electrons are delocalized electrons. They are mobile electrons. They can move freely and conduct electricity. And of course, graphite is one of macrocovalent compounds with different uses. It can be used in pencils. It consists of soft layers. It is lubricant. And it's used in lubricant and used in electrodes, as it is very good conductor of electricity, and also it has a high melting point, so we use it as good conductor of electricity. Graphene, it is only one layer of hexagonal shaped structure. It's a very good conductor of electricity. It's used for micro uses. In making drugs, it's used for making transistors. It's used in different electronic uses. It has very small size, very good conductor of electricity, and also we have nanotubes. Nanotubes is very important in the coming days, inshallah. Fluorine carbon 60 or Buckminster pole. Buckminster pole, pole consists of 60 carbon atoms. It is used as semiconductor. It has surface sphere and not planar. Electrons cannot flow easily, and it has lower electron mobility. We can memorize also the shapes of our carbon allotropes. We have fluorine, graphite, carbon nanotubes, and carbon 60. I hope it be useful for you. Question 8. Reaction pathway diagram is shown. In the reaction, we have relation between energy and progress of reaction. We have reactants and products. According to the diagram, we can say that the energy of reactants is higher than the energy of products. As the energy of reactants is higher than the energy of products, we can say that in this reaction is one of exothermic reaction. When the reactants converted into products, the reaction will release energy. Delta H of the chemical reaction is negative. But although the reaction is exothermic reaction, but we need amount of energy to start the chemical reaction. The amount of energy required to start the chemical reaction is known as the activation energy. Activation energy is the least amount of energy required to start the chemical reaction. In our chemical reaction, we can say that delta H of the exothermic reaction is the value of K. When the reactants converted into products, we will have amount of energy released known as K. It is the change in enthalpy of the chemical reaction. And to convert reactants into products in exothermic reaction, we need to have amount of energy equal to M. We need to have amount of energy equal to the activation energy. But if we start to convert the products into reactants, if we start to go backward, we are talking about endothermic reaction. Endothermic reaction means the energy of products is less than the energy of reactants. So, the products of particles need to gain amount of energy equal to L plus M, equal to O value. So, we can see this from the following diagram. In exothermic reaction, we have relation between potential energy and reaction progress. So we have relation between reactants and products. Energy released is the red part and activation energy is the blue part. But if we start to talk about endothermic reaction, the amount of energy required to convert reactants to products will equal to the blue value, equal to delta H plus the activation energy. So we can answer the following question easily. We have relation between enthalpy change for the forward reaction. Forward reaction is exothermic. So the enthalpy change delta H equal to K value. It is the change in enthalpy. The next choice, activation energy of reverse reaction. The reverse reaction is endothermic reaction. So we need to have amount of energy equal to delta H plus activation energy. So we have O value. Okay. Next question. X is either chlorine or an oxide of chlorine. X reacts with water under suitable conditions to form two acids, hydrochloric acid and HClO3. In the mole ratio, HCl is 1 to 5 HClO3. What could be X? This equation we studied it before in the chapter of halogens, group 7 or group 17. So we can have the following equation. The first equation, second equation, third and fourth. From the equations we can say that when ClO2 reacted with water, we will have 5 moles of HClO3 plus hydrochloric acid. So the correct answer is 9. It is just for memorizing the equations. Okay, next question. Ethyl ethanoate undergoes the following reaction. At first, we have the ethyl ethanoate plus water in hydrolysis reaction to form ethanol plus ethanoic acid. In this reaction, we can see that equilibrium constant Kc equal to 0.27. Equal amounts of ethanoic acid and ethanol are mixed together and allowed to reach equilibrium. At equilibrium state, the concentration of both ethanoic acid and ethanol were 0.42 mole per decimeter cubic. What is the concentration of ethyl ethanoate at equilibrium? To calculate the concentration of ethyl ethanoate at equilibrium, we must know specific information. In these reactions, before we start to calculate initial concentration of reactants and products, change in concentration of reactants and products, and at last at equilibrium we calculate the final concentration of reactants and products. But in our reaction we don't have any information about initial and change. We only have information about equilibrium state. So we will start to calculate the equilibrium constant related to the equilibrium state. We can say that at equilibrium we have the chemical reaction. If we start with X of ethyl ethanoate plus X of water, will form concentration of 0.42 mole per decimeter cubic of ethanol plus 0.42 mole per decimeter cubic of ethanoic acid. Equilibrium constant Kc equal concentration of products by concentration of reactants. So, equal to concentration of ethanol times concentration of ethanoic acid divided by concentration of ethyl ethanoate times concentration of water, equal to 0.42 mole per decimeter cubic times 0.42 mole per decimeter cubic divided by x squared. So we can say that x squared by mathematics calculation equal to 0.6533. X equal 0.808. We can say it's approximately 0.81 mole per decimeter cubic. So it is the correct answer for question C. Thanks for watching our video today. Inshallah, we will complete in the next videos from question number 10, question number 12 up to question number 20. I hope that you have more information from the video. See you soon. Don't forget to make share and subscribe and comment for our channel. See you later. Assalamu alaikum.